Hello friends, we have already seen how the principal views of an object can be represented using orthographic projections. This method is useful in surface identification of an object. In this session, we will discuss one of the important concepts in engineering drawing, that is an auxiliary view. It is an orthographic view which is projected onto the auxiliary planes. The auxiliary planes are of two types. First is auxiliary inclined plane AIP and second is auxiliary vertical plane AVP. AIP is always perpendicular to VP and inclined to HP at an angle theta. Projection on this plane is called as auxiliary plane or auxiliary top view. On the other hand, AVP is always perpendicular to HP and inclined to VP at an angle alpha. Projection on this plane is called as auxiliary elevation or auxiliary front view. First, we'll understand the need of an auxiliary view. For this, let's consider an example. Now look at the object which is placed in the first quadrant. The surfaces are projected onto the principal planes of projection. So these are the orthographic projections of the object. However, this object has a surface ABCD which is not parallel to any of the reference planes. Here, inclined surface ABCD is shown in all the three views. Observe carefully. Which view gives its true shape and size? The answer is none of them. Then how can we represent the surface in its true shape and size? The answer is we can set up one or more planes, that is an auxiliary plane parallel to the inclined surface ABCD. Now let's project the inclined surface onto it. By doing so, we can show its true shape and size. Observe that the front view of the slant surfaces when projected as an auxiliary view shows its true shape and size. Let's see the reason why this happens. Let's see the procedure to draw the auxiliary views. Draw a new reference line x1, y1 representing the auxiliary inclined plane. This line will be inclined at an angle, say theta, to the reference line xy at any distance. This line x1, y1 will be parallel to the slant surface edge view. Next, project the endpoints of the surface's edge view perpendicular to x1, y1. Extend the projectors long enough above x1, y1. Now, measure the distances of the endpoints of the surface ABCD from the respective view and mark them on the perpendicular projectors above x1, y1. Let's join all the points obtained. This is the required auxiliary view showing the true shape and size of the slant surface ABCD. So friends, we can construct the auxiliary view by the above mentioned procedure. We shall see some more applications in the next sessions.